Okay, so this is a review of how to graph absolute value functions back from Algebra 1. As you can see from the two pictures in the upper left and the upper right, absolute value functions are a V shape. Sometimes they open up, sometimes they open down. So I put on this first slide what a general equation looks like for an absolute value function. We call that general equation standard form. And that standard form tells us quite a bit about the graph. So the first thing that it's going to tell us about is where that graph is turning. So if you look at that graph up in the upper left-hand corner, that turning point is right here. And that the graph on the upper right corner, the turning point is here. And the equation will tell us the turning point. All we have to do is look at the h and the k, and we'll know where the turning point is. If you remember from Algebra 1, though, you have to be careful. It's not just h comma k as our turning point. It is the opposite of h comma k, meaning change the sign on the h value. So in this equation that I have to the right, y equals 5/3, absolute value of x minus 1 minus 6, the turning point, here's my h and my k. I just have to remember to change the sign on my h. So my h is -1, which means I need to make it a +1 in my turning point. And then my k I can keep the same, -6. So this graph will be turning at 1, -6. The second thing my equation will tell me about the graph is whether or not the v will open up or if the v will open down. And that comes from the a value, that number in front of the absolute value. If that a value is positive, my v will open up. If that a value is negative, it will open down. So in our equation, our a value is a +5/3, so we know that we're going to open up. And then finally, how do we go up? How steep are we? Are we not very steep at all? Is a very wide v? That also comes from the a value. And the a value is a, go ahead and put that in quotes, our a value is a constant rate of change, meaning you do the same thing over and over and over again. It's just a very simple stair step. And in our case, since it was a +5/3, we know that we're going to keep going up 5, out 3, up 5, out 3, over and over and over again. So let's do a little bit of practice with that. So here's our same equation that we were just working with. We have already talked about the turning point being a +1, -6, changing the sign on that h value. So I'll go ahead and plot that, +1, -6. There we go. And we talked about that the a value is positive, so we know we're going to open up, and we're going to go up 5, out 3, in both directions from our point. So I'm going to go up 5, 1, 2, 3, 4, 5, out 3 to the right, and up 5, out 3 to the left. And then I'm going to continue doing it until I'm off my graph. So up another 1, 2, 3, 4, 5, out 3, up another to the left, 1, 2, 3, 4, 5, out 3, and then one more time. Up 1, 2, 3, 4, 5, out 3, 1, 2, 3, 4, 5, out 3. There we go. That is my absolute value graph. So super simple, just a matter of remembering it back from Algebra 1. Okay, the second graph, it's missing a piece of it. So I'm going to just rewrite it right underneath here with all of our pieces in there. First thing is that the a value, the number in front of the absolute value, is not shown. So when that happens, it's a -1, in case you've forgotten. I'm going to go ahead and change that color. That way my 1 doesn't look like my absolute value bar. So there's a -1 up there. Then we still have our absolute value of x plus 2. And then the number that would be added at the end, that has no purpose of showing it, is 0, because when you add 0, it doesn't change it. However, it's nice to see it there, because then it reminds us what our turning point is. So our turning point, remember that's coming from our h and our k. Opposite sign of our h, keep our k the same. So I'll go ahead and plot that. -2, 0 is right here. And then my a value is telling me to open down And if I think of -1 as a fraction, it's -1/1. Remember, you can make any number into a fraction by putting it over 1. So this is saying to go down 1, out 1, down 1, out 1, down 1, out 1. So here we go, down 1 and out 1, both directions. And if you were being a fantastic student, you would fill up your whole graph with points. But so I'm not wasting your time tonight, we'll just do a few. So down 1, out 1 for that graph. All right, this last one, again, it looks like it's missing the number inside the absolute value, so let's just rewrite that really quickly so that everybody's on the same page. So what number would be inside of there that we would add to x that wouldn't matter? And it's very similar to the last one. When you add or subtract 0, it doesn't matter. And then the 7 was already there. So now it's much easier to see that our turning point was at 0. Now, opposite of 0 is still 0. And then we still have our 7. So over 0 up 7. There we go. And our a value is negative, so we're going to be going down 3, and again to make that into a fraction, over 1. So down 3, out 1, down 3, out 1, down 3, out 1. Down 1, 2, 3, out 1. There we go. Down 1, 2, 3, out 1. Both directions. And again, if you're being a fantastic student, you fill up your whole graph with points. Okay, very, very simple. Now, if we go forwards and I give you an equation and then you give me the graph, you should also be able to go backwards. So I should be able to give you the graph and you give me the equation. All we need is our turning point and our stair steps. That's all we really need. So on this first graph, I can see that my turning point is at -3, 0. Make sure not to write that backwards, 0, -3, that would be bad. And then our stair steps, if I'm looking for nice points, -2 does not have a nice point, but the next nice point is at -1. And then 0 doesn't have a nice point, but 1 has a nice point at 6. 2 doesn't, 3 does. If I go backwards from my turning point, -4 doesn't have a nice point, but -5 does. Not on -6, but yes on -7, and then again on -9. So we can kind of see that our stair step is going up 3 and out 2. So rise over run would put us at a 3/2. And since this opens up, it's a v that opens up, we know that we're going to need a positive 3/2. All right, let's plug into the equation as we know it. Just as a reminder, our equation is a absolute value of x plus h plus k. So for our first graph, we just said that we were stair-stepping 3/2, and it's positive. So I'm going to put that in the front, open up my absolute value. All right, my turning point was at -3,0. Now remember that that h value, when we put it in our equation, we have to change the sign. So this needs to say x plus 3, so that we know that it really means a -3 for a turning point. And then it's optional if you want to put that 0 at the end. If you like to see it there, just as a reminder to you that that's what it is, feel free. If you don't want to put it there at all, I'm okay with that also. All right, one more. So here the turning point is at +2, +6. And if you notice, our stair steps are perfect points every time. So that is 1/1. And since it's falling, we're going to say a -1/1, which is really the same as -1. So let's go ahead and write our equation out of that. Our stair step, we said, is -1/1, which simplifies to just -1. And then absolute value of x, we need to change the sign of our x value of our turning point, so x minus 2, and then keep the +6. If you didn't want to put that 1 as the a value and all you wanted to write was the negative, that is all right as well. Remember, if it's not there, we know that you mean a 1. Okay, so that is graphing absolute values in a nutshell.